The effects of pasteurization on vitamin C. Vitamins are organic compounds made of small molecules that living organisms need for normal growth and survival. There are two types of solubility when it comes to vitamins: water-soluble and fat-soluble. Vitamin C, or ascorbic acid, acts as an antioxidant in the body, helping break down iron, and is water-soluble. Vitamin C helps with skin, bone, and connective tissue. It helps create proteins needed for the creation and repair of tissue, and helps with blood clotting. Vitamin C deficiency can result in diseases such as scurvy and can cause heavy bleeding. There has been some debate whether or not pasteurization impacts the amount of vitamin C in orange juice, which we base our experiment on. Our hypothesis is that the pasteurization process creates a reaction that eliminates vitamin C in orange juice. To measure the vitamin C concentration in our samples, we use the interaction between vitamin C and the blue dye, DCIP. When vitamin C is exposed to DCIP, it oxidizes the DCIP to DCIPH, which is pink, and we'll further oxidize it to DCIPH2, which is clear. This reaction can be seen and measured in a spectrophotometer running with lights at 520 nanometers. This illustration shows the oxidation from DCIP to DCIPH and DCIPH2. The specific instructions for the dilution factor to be used in the spectrophotometer were given to us by our professor and are as follows: 500 milliliters of DCIP, 980 milliliters of H2O, and 20 milliliters of the sample we are testing. One orange was given to us by our professor, and we started by turning on the centrifuge and spectrophotometer so they would have time to warm up before use. And we cut the orange in half, squeezed it for its juice, and filtered it through a 4-ply cheesecloth into a single container to remove large matter that we are not testing for. We then pipetted the orange juice into 6 centrifuge tubes labeled A through F, A through C being our control variable our experimental variable that will be pasteurized with 3 replicants, and D through F being our control variable which will not be pasteurized. Once pipetted, we placed all 6 samples into a centrifuge on opposite sides of each other to maintain balance within the centrifuge, and had the centrifuge running for 2 minutes at 12,000 rams per minute as instructed by our professor. Once centrifuged, we pipetted the solution into new centrifuge tubes to separate them from the pellet of excess matter we are not testing for away from our solute. To ensure as little contamination from excess material, we repeated this step once again and pipetted each of them without mixing them into corresponding centrifuge tubes. Once centrifuged, we placed our experimental group, A through C, into a vat of 93-degree water to start the pasteurization process for 3 minutes. Then transferred our experimental group from the 93-degree water to an 80-degree vat of water and let them sit for 20 minutes. While they were pasteurizing, we measured and recorded the vitamin C concentration in our control group in the spectrophotometer as explained earlier, after setting a 0, of course, with a vial of clear water. After the pasteurization was complete, we let our experimental group sit in ice for about 5 minutes and then recorded the vitamin C concentration for A through C in the same manner as explained earlier. A standard curve was determined based on data provided to us by our professor. Standard curve was used with the dilution formula also given to us by our professor to determine the concentration of vitamin C in each sample. All samples except B of the pasteurization group had a dilution factor of 5. While in B we had an anomaly which caused too much vitamin C to be in and the results to be unreadable. So we had to do a dilution factor of 10 as instructed by our professor. We then averaged out we then took an average of both control and experimental groups to determine a percent difference between them, and we found a 10% difference in vitamin C concentration between our pasteurized and unpasteurized groups, ultimately supporting our hypothesis that pasteurization does eliminate an amount of vitamin C. This is the absorption versus concentration in the spectrophotometer, as shown here. Here we have the results of our spectrophotometer readings. We have the pasteurized, or experimental group, and our fresh, unpasteurized group here with their averages. As for our discussion, based on the 10% difference between our pasteurized and unpasteurized groups, we found our hypothesis to be supported. And according to the other class groups performing similar experiments, we found our experiment to also be supported by their data as well. While some sources of error in our data may have been the overuse of the centrifuge, the anomaly in sample B, the amount of replicants we used or another anomaly we were not able to observe. Comparing our results to other groups, we found in the Palladilla group, the Palladilla group showed a 1% difference. The Palladina group showed a 1% difference between pasteurization and non-pasteurized. However, they did use 5 replicants instead of our 3 and had considerable outliers. While the Crawley group also showed a 10% difference between unpasteurized and pasteurized. That extremely similar to our own. They did not have any extreme outliers like we did with Group B. These are my references. I apologize for not knowing how to reference the lab manual. And I apologize for the manner in which this video is being shown. My apartment doesn't have internet. I just moved in today. I spent all week moving out and moving in. And I'm in the library's 24-hour section. Thank you.